Hi everyone, welcome back to Pine Hollow Auto Diagnostics. We have a 2003 Chrysler PT Cruiser Turbo today that drove all the way from New York City for a diagnosis. Here it is. The car is in absolutely beautiful shape. The owner said it's originally from California, like zero rust, super clean, and it only has 135,000 miles on it. What's the customer complaint? He said about a year ago the check engine light came on and he started feeling this surging while driving. Also, his fuel economy went down and the car used to be pretty quick. It's not so quick anymore. So that's the customer complaint. Let's try to diagnose this one. So right off the bat, in OBD2 mode, we have two trouble codes set: P0031, P0037, heater control low, circuit low, bank 1 sensor 1, and bank 1 sensor 2. Now, well, what are the chances that two oxygen sensors would burn up at the same time? Not very likely. The owner, he also replaced the oxygen sensors with, a good name brand, no difference, and the car's still acting up. He said on the highway it's decent, but for one tank of gas you can barely get 200 miles. So this thing is sucking the gas pretty hard and has low power. So it's probably running rich. Let's take a look at some live data and see what's going on with these oxygen sensors and the fuel trims. So first thing that you want to check is which monitors have run. You can see catalyst not ready, evap not ready, and O2 sensor monitor not ready, and O2 sensor heater is not supported. That's interesting. So the owner said that the last time the codes were cleared was like a month ago. So this thing will not run monitors if there's something wrong with the heater circuit for the oxygen sensors. Kind of makes sense. Next step, let's take a look at some live data and take this thing for a test drive. Okay, so we have 8 data PIDs here. This is a 2003, so fairly standard, 2 oxygen sensors, 4-cylinder. Look, we're in open loop drive because of those fault codes. There's the intake manifold absolute pressure, RPM, TPS. So the fuel trims, the short term is disabled, the long term is showing 3.9. Bank 1 sensor 1 is right in the middle. Is that a bias voltage? I don't know. Bank 1 sensor 2 is 1.275. Now it depends on the strategy. Some sensors start high and then as they warm up they get into their operating range. So what we can do is raise the RPMs up a little bit and see if anything happens. Are these sensors responding? Okay, there you go. So it looks like on a fuel cut, bank 1 sensor 1 did respond. Bank 1 sensor 2 is just stuck high. Okay, let's turn the key off and clear the code and see if it tries to go into closed loop. Key off. Key on. Clear fault code, yes. And then read fault code. Let's see if it's a hard fault. Does it do the check right away? Okay, so no fault code. Let's read the live data again, start it up, and see if it tries to go into closed loop. Take manifold pressure, short-term and long-term trim, and then these oxygen sensors. So 8 data PIDs. Graph that. So it's an open loop. Let's start it up. So see, they're both starting high. That just means the sensors have cooled down. Okay. That one is now in operating range. Short term is still asleep. I'll raise the RPMs up a little bit. Look at that. Short term just tried. Now it's back to 0. OL drive. So I'm sure it set the code look, it says closed loop at OL drive. Okay, so try going to closed loop and then back into open loop drive. Let's see if it set both codes. Boom, right away, both heater control circuits. Okay, let's still take it for a drive while looking at live data, but we're going to go after these heater control circuits. Another one of the customer complaints is very loud suspension, especially on this gravel road. It sounds like something's going to fall off on the front end, so we'll take a look at that once we pull it in. No, yeah, it's not happy. We have, sounds like detonation, and I don't feel the turbo boost. It's really, So Gabriel, before the check engine light came on, you could actually feel the turbo? Yes. Like it was good? Mm-hmm. Okay. And let's take a look at the graphs. What are the oxygen sensors doing? It's low. Bank 1 sensor 1 is low. And it stays in open loop. So the downstream sensor did warm up on its own because we're driving. Okay, bank 1 sensor 1 went rich for a little bit. Now it's 0.8. Okay, so in open loop, it probably won't even spool the turbo because it wants to preserve the engine. So all these problems are related. So for a little while there on the way back, it did stay in closed loop. You can see that it was in control. The oxygen sensor actually was high, and the power felt a lot better. We didn't hear that detonation sound. So this is the whole entire issue with this car, is the heater circuits for these oxygen sensors. So let's get back to the shop and diagnose that. Alright, under the hood of the PT Cruiser, here's a wiring diagram of the oxygen sensors, OE diagram. So these are the heaters and these are the sensing elements. So 0211 heater control, that's the upstream, and 0212 heater control, that's the downstream. Same connector, C2, and actually their neighboring pins, pins 17 and 18. First thing I want to do is disconnect C2 and just do a resistance measurement through the heaters to ground to make sure we have continuity. So 17 and 18 are going to be in the second row towards the end. And here is connector C2. And by wiring colors, we're on the right wiring colors. That's the brown and violet, and then the brown and orange is right next to it. So ohm meter, that's connected to ground, and you want to make sure that it's a good ground. If you touch something else metal, should show about 0 ohms. Okay, so let's check the first pin, pin 17. That's going to be, I guess, the downstream. 6.7 ohms. I'm happy with that. Totally fine. So that's going to carry about 2 amps if we put full current to there. Let's check the upstream. Same thing, 5.9 ohms. So the heaters themselves are good, so the wiring is good, heaters are good, ground is fine. We can hook up a test light, like a 1 amp test light, to make sure that it lights through both heaters, just to load test the circuit. And then we're going to focus on this engine computer. It's looking like a burnt up driver inside that box. Okay, next, test light in the 1 amp setting is going to light the tail filaments. So from battery positive through the test light pair to, let's do the upstream sensor first. So here we go. Okay, so I'm drawing about 0.7 amps because there's resistor, or the sensor has some resistance to it. And then checking its neighbor. Same thing. Happy with that. Nothing wrong with the oxygen sensors or the wiring from the computer or the ground. So ruled that out in literally 1 minute. What do we want to do now? Well, we can put a scope on here and see if the heaters are trying to turn on, and look at the scanner, see if they're being commanded on. I'm pretty sure they're just going to be stuck low, well, just like the code said. And that'll be the diagnosis. It's going to need a PCM. Alright, so we got a scope hooked up on the upstream and downstream heater control wires coming right from the PCM. Everything's plugged in. Let's just turn on the scope and fire the car up, see if those drivers are putting anything out. Alright, so it's 0 volts. Turn the key on. Absolutely nothing. Drivers are dead in the water. So we're done. Now my question is, no, this probably won't work, but can we feed 12 volts to those wires in the ignition on state just to keep the sensors hot? Would that make the computer go into closed loop and at least make this car drive better? So the customer just wants the car to drive better. If the check engine light comes on for some code but it still stays in closed loop, that would be a big win. So if we can maybe rig up a test light, 5 amp test light to both heater wires and just power it on with ignition on, that may or may not work. So with the key off, we got test light from battery positive, and we'll feed it into the heater wire. Let's see what happens. Something weird happened. Something got powered up and the fan starts going? Let's try it with the key on. Like I said, this probably won't work. I don't want to cook anything. What about with the car running? Let's turn the scope on. Let's see if it does anything. So this is the upstream. So that looks okay. Let's do a 5 amp. There's some current passing through there. Yep, so we're at 12 volts on there. Let's take a look at the scanner and see what the live data shows. Alright, so we've got the heaters powered up through 4 amp test light, both of them. So I jumped 2 channels together. So 4 amps going to 2 heaters are up to 4 amps. And you can see the voltages, about 10 volts on both. And what do we see on the actual car? Well, it's still not happy. It's still in open loop. But the sensors are much more responsive since they're being heated through the bypass. And you can see when it's in closed loop, it does its thing, but then it drops back into open loop just like it used to. So I don't think there's a good way around this. It needs a new PCM. It's still setting the same codes. So one thing I want to try is maybe just power those up from the ASD relay, so when the fuel pump is on, when the engine's running, then the heaters will be turned on. last thing to try, reset the codes, and just take it for a drive and see if it stays in closed loop more. Nothing to lose here, it needs a computer. Alright, last trick I want to try is feeding those heaters from the ASD relay, so it'll only be on when the car is running. Here's the ASD relay right in the corner. I popped it out, and then pins 30 and 87 are the load side. We want to feed it off, the load side going to all the other fuel injectors, whatever. So I determined that pin 30 was in this corner, the lights up test light going to ground, so the opposite corner must be pin 87. So I'm just wrapping a wire around there. We're going to stuff this in back in the fuse box, tie into that, and feed the heaters off of that wire. Alright, just a quick check that I have good power on that wire when the ASD is powered on, just going through my little test light. So I flip the key on. Ready? There's the fuel pump prime. Okay, very good. So now let's tie that through the 4 amp test light to the oxygen sensor heaters. Alright, here we go. Everything's hooked up. Scope, just one channel. We'll monitor the voltage on the heater circuits. We turn off channel 2. Off. Okay, so key on, here's a test. Yep. Ooh. There's actually some pulsing going on. It's interesting. We clear the codes. Clear fault code, yes. Read fault code. Come on. No fault code. Okay, let's find. I don't know. Let's try again. Key off. Key on. Okay, there's some stuff going on there. Read fault code. No check engine light yet. We're 9 volts. We saw some activity on there. I don't know what that was. Sure takes a while to read codes, huh? No fault code. Okay, let's read some live data. This, I'm not going to guess or hope for anything here. Fuel system 1, engine RPM, throttle position map. Raise the RPMs up a little bit. No way. No freaking way. I don't believe it. It's actually working. It's staying in closed loop like rock solid. That is unbelievable. It's, I mean, that test light, I'm like, there's nothing to lose. Let's just try. I want to see if the computer can be happy. I did not expect this to work out whatsoever. Honest to goodness. It's looking perfect. Like, it's happy. Let's see, shut it off. Key on. Okay, open loop. And I'm not going to touch the gas. Closed loop. Look at the short term correcting. Oxygen sensor's doing its thing. This is nuts. This is truly crazy. And there is some stuff going on over here. Now I'm wondering if we can jump straight power instead of going through a test light. Just simplify this whole thing. That way we'll need, is the ASD circuit's already fused. We'll look that up just to make sure. You know, what if we go through a straight fuse jumper instead of a test light? Will that work? It's totally happy. I mean, this is unbelievable. Closed loop, rock solid. Alright, next thing I'm going to try, instead of a 4 amp test light, we're just going to install a 10 amp fuse direct from ASD output to the heaters. So it's simpler, and if the car's happy with this, then we can make it permanent. If it's only happy with the test lights, that would be insane. So, key on. Okay. So now we're at 12 volts there. Let's look at our data. Graph that. Just achieved closed loop. It's working. It's happy. I don't know. Let's take it for a test drive, but this looks very promising. And let's make sure there are no trouble codes set. Just rock steady at battery voltage now. If it's happy, it's happy. Now, I don't know, the check engine light might come back on, but as long as it stays in closed loop, this car should drive much better and get better fuel economy and just be happier overall. No fault codes. Alright, so looking at the wiring diagram of this ASD relay, there is a fuse before the relay, which is good, so we're safe tying this to the oxygen sensor heaters permanently. We don't need to add an extra fuse or anything. So that's good. So let's take this car for a test drive. I'm going to lift it up, see what the horrible clunking sound is under the car, and hopefully this thing will be fixed.